Okay, let's look at some more examples regarding scientific notation. We finished 3A and B. Now let's look at C. Okay, for 3C, the question states 5 times 10 to the negative second kilograms minus 2 times 10 to the negative third kilograms. Right. Let's go ahead and change 5 times 10 to the negative second. Let's change that so that its exponent is negative 3. Now, this negative 2, again, means that your original number, or the number written in regular notation, was less than 1. So if you hop the comma to the left, you'll get a number that was less than 1. 0.05 was your original number. Now, if we want this exponent to be negative 3, it means we're going to have to hop the comma 3 times. In order to hop the comma 3 times and still end up with 0.05, this 5 needs to be written as 50 times 10 to the negative third. In that way, there's another spot that the comma needs to jump. So 1, 2, 3. Again, we end up with 0.05. So the number is the same. So 0.05 can be written as 5 times 10 to the negative second power, or 50 times 10 to the negative third power. So in order to subtract the values in part C, we're going to write 50 times 10 to the negative third kilograms minus 2 times 10 to the negative third kilograms. Now 50 minus 2 is 48. And since our exponents are the same, we can just go ahead and write times 10 to the negative third kilograms. So this is our answer. Okay, let's look at D. Okay, so look at problem D. Now this one is a little tricky because the units are different. The first part is 1.26 times 10 to the fourth kilograms, and then it's plus 2.5 times 10 to the sixth grams. Now it states here that we need to write the answer in kilograms. So we're going to have to convert grams to kilograms. Now we're going to get into some more detail with this a little later, but at this point you should know that there are 1,000 grams in 1 kilogram. Kilo for kilogram. Those are one of the prefixes that you need to learn, and kilo means 1,000. So there are 1,000 grams in 1 kilogram. Okay. So if we write 2.5 times 10 to the sixth grams, to convert this to kilograms, we are going to have to divide by 1,000. Okay. A good way to remember it, or to do this, let me write it down here, 2.5 times 10 to the sixth grams, is using what is called dimensional analysis, where you use conversion factors, and we will be getting into that next. But for the time being, since we know there are 1,000 grams in 1 kilogram, we can use that conversion factor. So for 1 kilogram, there's 1,000 grams. Okay. I purposefully put the grams in the denominator, so down at the bottom, so that our units can cancel. Grams need to cancel so that we end up with kilograms, because the answer needs to be given in kilograms. Okay. Now, 2.5 times 10 to the sixth power, okay, times 1 over 1,000. 1,000 is the same as 10 to the power of 3. Okay. We'll also look at this next. So this problem really introduces a lot of the concepts we'll be looking at next. But if you multiply or divide exponents, you just subtract them. So you'll do 6 minus 3. And you'll end up with 2.5 times 10 to the third. Okay. Kilograms. So if we look back at our problem, 3D, you have 1.26 times 10 to the fourth kilograms plus 2.5 times 10 to the third kilograms This just becomes a simple addition problem. Well, sorry, it's not quite simple yet because our exponents are not yet the same. So at least now we have the same units, but we still have the problem of the exponents not being the same. So let's go ahead and get the exponents to be the same. Okay. Let's make this 3 a 4. So in order for you to get the same number, if you write this out, it's going to be 2,500 kilograms. In order to have this exponent be a 4, you're going to have to hop your comma 4 places to the right. In order to do that, you're going to have to choose your number to be 0.25 times 10 to the 4th. In this case, if your comma is hopped 4 times to the right, 1, 2, 3, 4, you still end up with 2,500 kilograms, which was your original number. If you hop, I'm just going to repeat that since you guys couldn't see the video. If you use 0.25 and you hop your comma 4 times to the right, 1, 2, 3, 4, you still end up with 2,500 kilograms, which is the same as your original number. Okay, so we can rewrite this as 1.26 times 10 to the 4th kilograms plus 0.25 times 10 to the 4th kilograms. Now 1.26 plus 0.25 equals 1.51. Our exponents are the same, so we can just write times 10 to the 4th kilograms. Don't forget your units. Okay? Right, let's look at problem 4. Okay. The directions say, solve each problem and express the answer in scientific notation. Now here, we're dealing with multiplication and division. Now multiplication and division is much easier than addition and subtraction because it doesn't matter if the exponents match or not. If the exponents, if you're multiplying, all you do is you add the exponents. If you divide, you subtract the exponents. So for part A, 4 times 10 to the 2nd power times 1 times 10 to the 8th power, you're going to multiply your coefficients. So 4 times 1 equals 4. And you're going to write times 10 to the power of, you're just going to add your exponents. 2 plus 8, which is 10. There you go. That's your answer. Okay. For part B, we're multiplying again. So we are going to be adding our exponents. So 2 times 3 is 6 times 10 to the power of -4 plus 2, which is -2. Now for part C, we're dividing, which means that we are going to be subtracting our exponents. Here we have 6 times 10 to the power of 2 divided by 2 times 10 to the power of 1. So we're going to subtract these exponents. So 2 minus 1. Okay, 6 times 2 is 12 times 10 to the power of 2 minus 1, which equals 1. Here for part D, 8 times 4 is 32 times 10 to the power of 4 minus 1, which equals 3. Okay. Now, back on your notes, slide 15 and 16 just summarizes the notes we took. So do go ahead and read through it and make sure you understand it. And make sure that the notes are complete. And so at this time, I would like you guys to page to the back of your Chapter 2 note packets. You'll see that after the PowerPoint slide, there are worksheets. Okay? I want you to now work on page 6. The worksheets are labeled or numbered rather at the bottom of the pages. I want you to do page 6. The title is Scientific Notation. And I want you guys to work on page 8. And its title is Calculations Using Significant Figures. I also want you to do page 13, numbers 1 through 7.